The planet Mars has two moons called Phobos and Deimos. These moons are named after the son of Ares, who is the Greek god of war and the equivalent to Mars. They're among the smallest moons in the solar system, and each one reflects only about half as much sunlight as Earth's moon. Both moons appear to be made of C-type rock. C-type refers to a broad category of asteroids that are made up of clay and silicate rocks. Because of this appearance, it's thought that Phobos and Deimos were asteroids that became captured into orbit around Mars. Let's take a closer look at the Martian moons. Phobos and Deimos were discovered in 1877 by Asaph Hall. For years, scientists believed that Mars had no moons. Johannes Kepler suggested the possibility of two Martian moons, but purely from a numerical standpoint. Because Earth has one moon, and at the time Jupiter was known to have four, he reasoned that Mars, the planet between Earth and Jupiter, must have two moons, which is that's not at all how moons work, but he was right. Wrong formula, right answer. You can't argue with the results. In 1877, Asaph Hall made a very thorough study of Mars and engaged in a pretty frustrating search for any moons orbiting it. He was about to abandon the effort one night because he just couldn't find any moons of Mars, but his wife, Angeline Stickney, urged him on. He discovered Deimos the very next night on August 11th, and then Phobos 6 days later on August 17th. He had so much trouble finding them because both moons were hidden in the glare from Mars. It probably also didn't help that both moons are incredibly small and dark. Phobos and Deimos for sure would have been discovered eventually, even if Hall gave up his search, but now he's forever remembered as the one that found them first, so that's pretty neat. The main theory about Phobos and Deimos' existences is that they were captured asteroids. In theory, Jupiter's powerful gravity could have kind of nudged these things out of the asteroid belt and into orbit around Mars. However, there are some issues with that theory. For one, there's the moon's orbits, which are stable and nearly circular. Captured bodies, on the other hand, tend to move more erratically. A planet's atmosphere could slow down and stabilize captured bodies, but the atmosphere of Mars is insufficient to achieve this. An alternative explanation is that Phobos and Deimos formed around the same time as Mars from debris left over from the creation of Mars. Gravity could have drawn together the remaining rocks to form the two oddly shaped moons. Phobos and Deimos also could have formed similarly to how Earth gained its moon. A collision might have blown chunks of Mars into space, and then these chunks later came together to form the two moons. Along the same line of thinking, an earlier, larger moon could have been blown apart by an impact and eventually left only Phobos and Deimos as its remnants. There's a decent number of possibilities as to why these two moons exist, and that's kind of just how it is with space. You don't always have one concrete answer to something. Phobos is the larger of Mars's two moons. It revolves around the planet extremely quickly, completing 3 orbits in one day. It moves from west to east across the Martian sky. At a distance of only 3,700 miles away from the surface, Phobos orbits closer to its primary body than any other moon in the solar system. It's so close to the Martian surface that from the planet, it can't always be seen in some places. The orbit of Phobos is tilted only 1 degree with respect to the Martian equator. From the Martian surface, it appears to be about 1/3 as wide as Earth's full moon. One of the more notable things about Phobos is that it's approaching Mars at a rate of around 6 feet every century. At this rate, in around 50 million years, Phobos will either crash into the red planet or break up into a ring. There are a bunch of grooves and stretch marks on Phobos' surface that could be early signs of it beginning to break apart. But these marks could also be a result of the massive impact that created Phobos' largest crater, which is named Stickney Crater after the wife of Asaph Hall. Stickney Crater is around 6 miles wide, and it takes up about half of the moon's surface. Images of the crater from the Mars Global Surveyor show that it's filled with fine dust, and these images also contain evidence of large boulders sliding down the slopes. The impact that created Stickney Crater probably almost destroyed Phobos, and it barely survived. It has gouges from thousands of meteorite impacts, so this guy has not had an easy life. The surface of Phobos has been almost pounded into powder by all the impacts it's endured. Some of these impacts started landslides, and these landslides left dark trails down some some of the slopes of craters. Phobos is pretty darn cold. At their highest, temperatures only reach around 25 degrees Fahrenheit, and the lowest temperatures are closer to negative 170 degrees Fahrenheit. There's nothing on the moon that can retain heat, so what little heat it does gain from the sun quickly goes away. Although Phobos may be a captured asteroid, as implied by its appearance and composition, some scientists have shown evidence to contradict this. A recent model suggests that Phobos might instead have once been a ring around Mars. This ring would have been caused by a large impact about 4.3 billion years ago, and its approach to the planet will one day turn it into a ring again. In fact, the model goes so far as to state that this cycle may have already happened 3 to 7 times. Phobos may just be the latest phase of the process. It gets pulled towards Mars, breaks up into a ring, and then that ring comes together to form a moon that then gets pulled back towards Mars and breaks up, and you get the point. The moons wouldn't be the same each time, though. The model predicts that each newborn moon could be about 5 times smaller than its predecessor. Debris from this process could have coated Mars every time another moon broke up. This could explain some unusual sedimentary deposits on Mars that have no other explanation for being there. If this model is correct, and this is in fact what has been happening to Phobos since its creation, then that's pretty sick. The little guy is just doomed to keep getting torn apart and then remade over and over until one day there's nothing left. Deimos is the smaller of the 2 Martian moons, and it orbits Mars once every 30 hours. At an average distance of about 14,576 miles away, it's much further from Mars than its brother Phobos. Its orbit is tilted 2 degrees with respect to the Martian equator. It's also less irregular in shape than Phobos. The largest crater on Deimos is about 1.4 miles in diameter, making it only about a fifth the size of Phobos' largest crater. It lacks the grooves and ridges that are seen on its fellow Martian moon. Although Deimos is just as heavily cratered as its brother, it has a smoother appearance because of the partial filling of some of its craters. When the moon is impacted, a bunch of dust and debris are ejected out of it because the little guy doesn't have the gravitational strength necessary to hold on to it. However, the gravity of Mars comes in clutch here and keeps the debris in a ring around the same region in which Deimos orbits. As Deimos revolves around Mars, it then picks this dust and debris back up, and that dust then fills some of the craters to give it a smoother appearance. It's like a really weird and complicated skincare routine. In the Martian night sky, because Deimos is so small and far away, it looks more like a star than a moon. When it's full and shining at its brightest, it kind of resembles the way Venus looks from Earth. While Phobos is on a collision course with Mars, Deimos is heading in the opposite direction. Literally, it's slowly drifting away from Mars. So, one day, Mars might not have any moons at all. There's not a whole lot left to be said at this point, but I'm still going to say the exact same thing that I do every single time I make one of these videos. Phobos and Deimos? Pretty cool. This one is shorter than most of my other solar system spotlight videos, but that's just because there's not a whole lot of information that I could find on Phobos and Deimos. There is some more on Phobos, which makes it seem like Deimos is kind of ignored, but for the most part, this is really just all I was able to find. Oh well. It was still cool to learn about these little guys. I hope you enjoyed this pretty brief exploration of the Martian moons. Thanks for watching, and have a good day.